Okay, we are at time, so we're going to get started. We've got a quick 15-minute presentation on the work we're doing around carbon emission savings, with Alvarium, with the concept of data confidence fabrics. So with me, I've got Matt and Steve. Maybe you guys do a very quick intro, kind of your roles and respective companies. So Matt.
Yeah, so I'm Matt Yarger. I am currently the head of sustainability at the IOTA Foundation. I work on our climate and sustainability projects and have been building out one of the platforms that we're going to talk about here a little bit today, and building out the relationship with Jason and Steve at ZEDEDA and Dell, among others in the Alvarium ecosystem. So
cool. Yeah, Steve.
Yeah, thanks, Jason. My name is Steve Todd. I'm a fellow in the Office of the CTO at Dell Technologies. My background is delivering storage systems that deliver trusted data. And my research area of interest is delivering trusted data on the edge.
Very cool. Yes, also a big movie quote buff. Shared a lot over the years. Very good. So thanks, guys, for joining. So let's dive in. So first, kind of Project Alvarium, what we've been working on, between Dell and, when I was at Dell previously with you, Steve, and of course now at ZEDEDA and Matt, we've been collaborating with the IOTA community for a while. Steve, you could take a minute or two, just kind of describe what we mean by data confidence fabric and what kind of problem we're trying to address.
Right. So this is just a very simple picture of a complex problem. As companies try and deploy applications out on the edge, the data and the applications have to cross through so much heterogeneity, right? Different vendors, different networks, different geographies, that by the time you bring these two things together, right, the applications and data coming from devices, can you trust the data, right? So, Jason and Matt and I, for several years, have been working on this idea of a new technology called a data confidence fabric, which means that as the data moves towards the application, you're keeping track of trustworthy handling, right? And here's an example, right? As the sensor data moves from a sensor to a gateway to an edge server, there's now an industry standard Alvarium SDK, right? A Project Alvarium, right? We've open sourced this technology that allows you to track, how is this data handled? Where did it come from? Where did it travel to? What trustworthy software and hardware components handled this data on its journey towards an application? And the real unique part about all of this is that once you see how it's been handled, you could actually calculate a confidence score, which gives your application some level of trust as to whether or not it can trust this data. So again, Project Alvarium is an Linux Foundation LF Edge open source project, and the three people here represent companies that are actually working on it: Dell, ZEDEDA, and IOTA.
Yeah, very cool. And we'll kind of talk a little bit more about that in context of the solution. So the POC that the IOTA folks have been leading. So with that, Matt, maybe set up kind of the scenario here, of the use case that we have been working on together.
Yeah, so as the last slide showed, it really creates a transparent audit trail for what's happening to your data from the point where the data is created to the point where the data is consumed and everything in between. With the carbon markets as a whole and carbon credits, the way that typically works is it's a very manual process, but there are different types of facilities that have a methodology, and there's thousands of different types of methodologies out there, all pretty proprietary in nature, not very transparent on which one you're supposed to use. But those methodologies calculate the emissions from different facilities, whether it's a vehicle, a building, an industrial facility, a landfill, biodigester, composting facilities, any kind of facility you can think of. You can start to measure the emissions, and these methodologies describe how you measure them. And then if those emissions are being reduced, or if emissions are being captured completely, they can then be audited and reported on, and the organizations that manage those facilities can earn carbon credits for them. So those businesses or those landowners will earn those carbon credits through that auditing process and reporting process. And then organizations that have a negative carbon footprint can go through the carbon markets and registries like Gold Standard and Verra, and they can buy these carbon credits to help offset the emissions that they're producing. Because if they don't have facilities or processes that are mitigating the emissions that they're producing and decreasing it proactively over years, then they have to have a way to interact with the market and incentivize others that are doing that for them through their businesses.
Right. So there's incentives, but there has to be transparency in how you do it between the regulators or the people that are paying the credits versus the people that are seeking the credits.
Mm-hmm.
Maybe describe kind of a little bit of the problem or how it's done today.
Yeah. So the way it's designed today is it's a very manual process. It's extremely lengthy and it's very cost intensive. So auditors have to go facility by facility or device by device or system by system more generally. And they have to look at the methodology that can measure what the emissions are currently. And then over time, they come back and they re-audit that to see what those emissions reductions are looking at year by year. Sometimes this is a 15 to 18 month process. I've heard of it being over a 24-month process as well. So it takes a long time. And this one audit can take 2 to 3 weeks just to go through and look at all the data at a minimum, sometimes, months just to look through the data depending on the size of the facility. And if it's auditing an entire business, then that can include hundreds or thousands or tens of thousands of facilities to get the total footprint of that business. And that can be a much longer process, sometimes 3 to 5 years. So there's a lot of non-transparency here. It's extremely convoluted process, very, very manual. It's very analog, a lot of clipboards, notes, spreadsheets, and there's a lot of room for human error. But the auditors take these, they report on them, and then those reports are verified for carbon credits for those businesses or those individual facilities.
Yeah, cool. And so then the idea here is to automate it a bit more, to streamline the process. And so that's kind of when you got involved with the project as IOTA and different partners. And so kind of applying Alvarium to the project to start from silicon, where data is generated as much as you can, although you still also have some manual elements. Anything to add kind of on setting up the problem as we lead into the actual solution that we worked on?
Yeah, there's a few different phases of this, but the phase we're in right now as a group is we're integrating into individual facilities so that we can start to get this data path put together. ZEDEDA is helping deploy these operating systems and systems with Alvarium and IOTA embedded into them to the edge. And then it's taking that data, processing it through the cloud over a distributed ledger as well, so that there's transparency on the data. So the data is actually coming from the sensors, getting set up into transactions in the facilities, and getting directly published onto a distributed ledger as an audit trail. So you can see it from each facility where the data is coming from and how it's coming up the chain.
Yeah, and this particular one is in Chile that we're working on.
And this one is really interesting. We did a pilot prior to this that was fully digitized already. So we did a digital readiness assessment and everything was sensor-based at the previous pilot. This one is the first pilot that we've had sensor-based and manual input data. So it's really nice with the data confidence fabric, because since manually input data has more room for error, that's reflected in the confidence that we have in that data. Because if someone's taking it and they're measuring, how much crop waste or animal waste was dropped off today, and they're inputting it, they might miss a zero or a comma, they might put a decimal in the wrong place, and that can mess up the data pretty significantly. But if it's automated, you don't have that same type of error. So having the data confidence fabric also helps incentivize accelerating digitization, because then there's a lot less room for error. And if something has a 30% data confidence rating because it's heavily manually based versus a 70 to 80% data confidence rating, then the carbon registries like Gold Standard have also said, if there's a higher level of confidence, then the carbon credits are worth more. So they're losing money by not digitizing over the long run. So it really helps with ESG investment and incentive models as well.
Right. Yeah, cool. So, and Steve, maybe add a little color to, the solution stack and kind of how data flows through. And maybe actually we'll start here just to set some context. This next one, in terms of like kind of who's involved and how data is flowing through, and then we'll flip back to the previous one.
Sure. So, Dell contributed a PowerEdge T140 server to the location in Chile. ZEDEDA helped us install EVOS, right, Edge Virtualization Engine operating system on the server. And we've also got another open source project, right? Project Alvarium on the server. And now we can connect sensors to that server and call the Alvarium SDK, which records confidence scores in a ledger along with the data. And what happens is then IOTA, working with Climate Check, can build that dashboard on top of the ledger as an application, right? So if you double click on that, what you see is exactly what Matt mentioned earlier, right? This particular site is a mixture of automation, right? At least 5 different sensors, right, that are measuring, for example, how much methane is being captured off of the feedstock and routed and not emitted into the environment. How much electricity is being generated in the facility in order to support the biodigester, for example. So those are all automated, collected pieces of data, but we still have humans in the loop, right? Measuring the weight of the feedstock that's in the truck, writing down in a spreadsheet how many miles did that truck drive, right? Because there were emissions that happened as the truck were driving. So anyway, all of that data, both manual and automated, gets brought into the Dell server. Alvarium then annotates the trustworthiness, right? As it goes through the system. And this slide basically shows, hey, the automated data, you can do a lot more annotation, right? That says, hey, my server is a trusted server. I check the signatures on the data. They're valid. The data was transferred using TLS, so it's secure. All of that annotation information goes into the ledger alongside the green data elements. The manual data elements, there's really not much we can do to talk about their trustworthiness, but we still say, hey, it was entered into a trustworthy server. So now the dashboard sits on top of the Tangle, and the Tangle contains 3 types of elements: automated data and manual data, which can then be rolled up into an emissions savings calculation. But you also have the confidence that rides alongside of it, which allows Matt's team and the Climate Check team to do some pretty cool things from a user interface perspective.
Yeah. So speaking of, so the example of the UI that the team built working with Climate Check, I don't, Matt, if you want to talk a little bit about the how it all manifests in this sense.
Yeah, so we've got a really simplistic overview in the beginning that tells the baseline of what the measurements for the emissions reductions over the past month are, and then also what the annualized emissions reductions are. So you can start to see some emissions projections pretty directly based on the near real-time data coming in. And then based on how much is automated, how much is manual, and then what's happening to that data through the process, how consistent that data is coming into the system. There's a measure of that data confidence directly up front, saying there's an 80% confidence in this data, which really helps the auditors know like how much trust can they have and how deep do they really need to dig, or where are the weak points in this system for the reporting. Because now with a system like this, they don't have to fly down to these facilities more than that first time. They don't have to go every year and re-audit the facility. They can come in, they can check it monthly. And instead of it being a 15 or 18 or 3 to 5 year process sometimes, they can have these carbon credits and systems reporting monthly, and then these organizations and businesses getting reimbursed for their emissions reductions on a monthly basis instead of sometimes 3 to 5 years later.
Yeah, makes sense. Yeah, and I mean, so a couple points we'll wrap up here in a minute, but obviously there's a reason why it's rooted. It has an open source element. IOTA, of course, as a community and consortia. You can't. It's very hard to drive transparency without some level of transparency, and open source obviously contributes to that. Of course, you then can build various different types of solutions around that, services. In this case, it's certainly altruistic from an environmental standpoint, but there's lots and lots of different use cases. And the other thing, I would mention is that, the idea here is you can kind of mix and match components as you go and sort of grow. And maybe you have manual, in this case, maybe there's manual stuff today, but over time you can start, it's modular, you can kind of grow. Let me go figure out how to digitize the mileage for that truck, or, introduce, a new way of sensing that particular element to increase the confidence score, but you don't have to do it all at once. So anyway, in closing, maybe let's talk about a little bit about kind of some of the future areas we see. I mean, of course, this could be anything. This could be business B2B2C. It could be interconnected supply chains, retail, crossover into the home. There's just so many different potential elements. But as a community, we decided that it really makes sense to start with environmental use cases for a variety of reasons. Maybe Matt and you and Steve just kind of chime in. Like, where do you see some of the next applications that we can tackle as a community?
Yeah, so I think that the start with where we're going with these stable and non-mobile solutions in industrial facilities is a really great starting point for us. And now we're already seeing with the organizations we're talking to and the customers that are getting involved that the first few facilities have gone well, and they really like the way it's processing. And there's interest in scaling these out to thousands of facilities so you can have a much larger overall picture. So I think, one, there's a huge business opportunity here, and I'm really excited about that. Two, from the environmental side, tracking really fragmented ecosystems like smart cities, I think, is a great example, because every building owner is different in a city, especially one like Austin or New York or some of these major metropolitan areas. Integrating a data confidence fabric into the buildings and measuring the emissions of the buildings and the energy use, and helping incentivize like when to use the grid or how to add sustainable energy, I think is going to be a really huge initiative that can come behind something like this. And then also with the transition of gas to electric vehicles, there's a lot that can come into play with that. And there's a lot of different factors in how to measure that. But this is a really lightweight way to share just enough information from all the different stakeholders in the data production ecosystem or the data path that gives you a holistic understanding of like scope 1, 2, and 3 emissions. And it's just really exciting to see how it's growing and the positive feedback we're getting from really large international organizations.
Very cool. Yeah, Steve, any closing thoughts?
Yeah, just, Dell in particular is very excited about the infrastructure use case, right? Because we've continually drove the efficiency down in terms of the emissions, right? Less emissions from power consumption of our data center components. And our customers are looking for a way to satisfy audits to show that they are indeed complying with their local or regional regulations. So exciting areas that we can bring this into next.
Yeah,
for sure. Yeah. So energy, this whole notion of environmental, as I said, it's one area that this is very applicable for. It makes sense. I mean, the energy ecosystem is going through a lot of changes, today, electrification, there's regulations. Being in Texas, I know first and foremost that our grid, Matt, you too, that our grid is a little old and got some issues, just from a pure utilities standpoint. So figured this was a great starting point, but we encourage you guys to check out alvarium.org. You reach out to us if you'd like to get involved, whether it's on these types of use cases or, it's certainly very applicable to others. The key here is this is about the confidence scoring and the fact that it's rooted down into the silicon itself and starts there. Very complementary to other efforts that are focused on data trust in the sense of smart contracts and semantics, whether it's International Data Spaces, Gaia X, you name it. There's a bunch of other great efforts out there that we think are complementary. So again, we encourage you guys to check it out, learn more, dive in. And with that, Matt and Steve, really appreciate it.